All right, let's take a look at the practice tests. For the instructions, we're asked to find the period, phase shift, vertical shift, and a pair of consecutive vertical asymptotes. We're asked to sketch the graph. All right, before we look at any problems, let's go ahead and do a quick review of some things that we need to know if we're trying to graph the tangent function. I'll talk about the cotangent function later on. Again, before we start, I also want to remind you that in this section, we're just thinking about the concept. How could I graph the tangent function or the cotangent function if I had to? So if I had a piece of paper and a pencil and I wanted to graph it. It does not have to be a perfect graph. You're just trying to learn the concept. If you want to graph something as we move out of this chapter, you're going to use graphing software, so something like Desmos. Generally speaking, in your book, when they first show you this, you're going to graph y equals tangent of x over one cycle, or one period if you want to say it that way. And the way they're going to show this to you is they're going to say y equals the tangent of x, where x is greater than negative pi over 2 and less than pi over 2. So why are negative pi over 2 and pi over 2 not included? Why do we have vertical asymptotes at those values? Well, if you go back to the definition of the tangent function, so the tangent of x is equal to the sine of x over the cosine of x. Well, remember that when you have a fraction involved, you want to guard against division by 0. We know that division by 0 is undefined. So we know that wherever the cosine value is going to be 0, so odd multiples of pi over 2, 3 pi over 2, 5 pi over 2, also negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So wherever that's going to happen, the tangent value is going to be undefined. So something like, let's say, the tangent of, let's go pi over 2, and this is equal to the sine of pi over 2 over the cosine of pi over 2. We know the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So again, 1 over 0, this is going to be, by definition, undefined. So this is undefined. Now this is going to happen, again, anywhere where the cosine value would be 0, so we just say odd multiples of pi over 2. So your first goal, when you sketch the tangent function, is to find what we call two consecutive vertical asymptotes. So if you're looking at y equals the tangent of x, again, we just use negative pi over 2 and pi over 2 for the two consecutive vertical asymptotes. Let me write that out. So the vertical asymptotes for this guy, you have x equals negative pi over 2, and you have x equals pi over 2. So those two guys. So if you get something that's different, let's say you had something like y equals the tangent of bx, well, all you have to do is take the bx here and plug it in for x right there and solve the inequality for x. So in other words, you would set up bx is greater than negative pi over 2 and less than pi over 2, like that, and that would give you your interval over which you can sketch the graph. You would have the leftmost value here, whatever that is, that would be your leftmost consecutive vertical asymptote that you're finding, and whatever this rightmost value is once you've solved this, that would be the rightmost consecutive vertical asymptote, and so you would just set those up on the graph. The other thing is, you need to find the 3 key points. So we talked about this in the lesson. You should know these 3 points from the basic y equals tangent of x graph. So something like this one right here, which is going to be negative pi over 4, comma negative 1. This one right here, this is going to be 0, comma 0. And then this one right here, this is going to be pi over 4, comma 1. So you need to memorize those points. When you get to your other tangent function that you're trying to graph, you can either use graphing transformations only to figure out where these guys are going to be, or you can use a combination of things. What I like to do is stick with the book method. And what they do is they find the period, which again, when you're working with tangent, it's going to be pi. So if you have something like y equals the tangent of bx, well, the period for this, so the period here is going to be pi over b. So the standard period divided by b, whatever that coefficient of x is. But let's erase this and just go with in terms of the y equals tangent of x. So we know the period is pi. If you want to find the quarter period, because this guy right here, this point is at the first quarter, this is halfway, and this is the third quarter. So if you want to find the quarter period, it's just pi over 4. And so to get the x values for the next thing that you're working with, you just add a quarter period. In other words, you could start right here at negative pi over 2, and you add a quarter period. So I add pi over 4, so this becomes negative 2 pi over 4 if I get a common denominator, plus pi over 4. And what does that give me? It gives me negative pi over 4, and you'll notice that that is the x value for this guy right here, so a quarter of the way through. If I want to get to this guy right here, the x value is going to be 0, because all I have to do is take negative pi over 4 and add a quarter period, which is pi over 4, and you know that's going to be 0. Then if I want to get to the next guy right here in terms of the x value, you're going to take 0, add a quarter period, which is pi over 4, you're going to get to pi over 4. Then if I add another quarter period, I'm going to get to my next asymptote. So pi over 4 plus pi over 4, that's 2 pi over 4, which is going to simplify to pi over 2. So it's just going to follow that pattern if you're finding x values. So if you're starting at a vertical asymptote, you add a quarter period to get to the x value of your quarter point, and then you add a quarter period again to get to the x value for the midway point. You add a quarter period again to get to the x value for the 3/4 of the way point. And then if you add a quarter period again, you're going to get to another vertical asymptote. In terms of the y values, you can plug into the function, or you can use just graphing transformations. So I'll talk about that on the first 2 problems, and we'll settle into a method on that. Now, the other thing I would say is that for the y values, you really don't have to worry about them too much, because for the first quarter point, everywhere it's going to be the same. So it's always going to be at -1 here. When you think about y equals the tangent of x, it's always going to be 0 for the halfway point, and then it's always going to be 1 for the 3/4 of the way point. So finding the y values, once you found it one time, if you're sketching more than one cycle, it's not a big deal. That's just something you can copy over and over and over again. It's not going to change. Always the same for the first quarter point, then it'll always be the same for the halfway point, and then it'll always be the same for the 3/4 of the way point. So you don't have to worry about that. All right, let's take a look at the first problem. So we have f of x equals 2, tangent of x over 2 minus 5 pi over 6, and then minus 2. So again, going back to what we just talked about a moment ago, if we look at y equals the tangent of x, we graph this as x is greater than negative pi over 2 and less than pi over 2. So what we can do is just modify this inequality, because now the argument is not x, it's going to be x over 2 minus 5 pi over 6. So let's say that x over 2 minus 5 pi over 6 is greater than negative pi over 2 and less than pi over 2. Let me slide down here a little bit. What I would do personally is clear the fractions. They're very tedious to work with. You have a denominator of 2, a denominator of 2, a denominator of 6, and a denominator of 2. So multiply everything here by 6. That would be your least common denominator. And so this right here would cancel with this right here and give me a 3. This would cancel with this and give me a 3. This would cancel with this, and then this would cancel with this and give me a 3. So 3 times negative pi is negative 3 pi. This is less than 3 times x is 3x, and then minus. This canceled, so you have 5 pi. So this is going to be less than 3 times pi is 3 pi. Let me slide down here a little bit, and I'm trying to isolate x in the middle. So to do that, I'm just going to add 5 pi to each part here. So this is going to cancel. So let's write that 3x is greater than negative 3 pi plus 5 pi, that's going to be 2 pi, and it's going to be less than 3 pi plus 5 pi, that's going to be 8 pi. As a final step, again, if you're trying to isolate x, let's divide each part by 3. And so this is going to cancel, and you're going to have that x is greater than 2 pi over 3 and less than 8 pi over 3. Let me put a little border here, and let me put that the 2 consecutive vertical asymptotes that we're trying to find, so v period, a period, we're going to list 1 as x is equal to 2 pi over 3, and then we'll say x is equal to 8 pi over 3. Now, in some cases, the book will not ask you for this. They'll say, just give me the asymptotes. So in that case, they want a formula to find all the asymptotes. So you could start with 2 pi over 3 or 8 pi over 3. It doesn't really matter. You could just say that it's x equals 2 pi over 3, and then plus, you need to know the period. So coming back up, this really is 1/2 times x. So the period for this guy, let me write this right now because we're going to need it. It's going to be the standard period for tangent, which is pi, and then divided by 1/2. It's the coefficient of x. So you can do that as pi over 1 times 2 over 1, which would be 2 pi. So this would be plus 2 pi n, where n is any integer. So this would be for your asymptotes if you're trying to find a formula for all of them. So that's something you can list. I'm going to get rid of that because I'm just going to focus on these 2. Now, if you go to the graph, which I've already sketched, and again, I have a link for you on Desmos if you just want to click on that to follow along. Here's your vertical asymptote. You have x equals 2 pi over 3, and then you also have the vertical asymptote where x is equal to 8 pi over 3. So that one. So again, the period is 2 pi. So if you keep adding 2 pi, so in other words, if you did 8 pi over 3 plus, you could write 2 pi as 6 pi over 3. Well, 8 pi over 3 plus 6 pi over 3, that's 14 pi over 3. So you're going to be at another one. But for right now, I'm just focusing on this right here. So what are these 3 key points? This one, this one, and this one. So let's go back up. Again, going back to what we talked about in the review, to go from here to the x value of the first quarter point, you just add a quarter period. In other words, here it's x equals negative pi over 2, that's the vertical asymptote. If I add a quarter period, which in this case, y equals the tangent of x, the period is pi, so the quarter period is pi over 4. Well, if you do negative pi over 2 plus pi over 4, you get negative pi over 4. So here the period is 2 pi. Let me write that so we have it. So the period is 2 pi. So the quarter period is going to be 2 pi over 4, which is going to end up being pi over 2. So it's pi over 2. Now you always want to look at this guy right here. So this is your leftmost consecutive vertical asymptote that you found. And you're basically going to say, well, if this denominator is 3, go ahead and convert this over to where you're going to have a common denominator. So this is 2 and this is 3. So the LCD would be 6. So just multiply it now. It's just going to make your life a lot easier. So this would end up being 3 pi over 6. So another way to just write pi over 2, again, just making your life easier. So start with 2 pi over 3, and then plus, let me get rid of this and make it better. You're going to add your quarter period. So 3 pi over 6. Again, all I'm doing here, so you can see this visually, I'm starting at 2 pi over 3, and I'm saying if I add a quarter period, I'm going to get to this x value right here. I don't know what the y value is, I'll get that in a moment, but if I take 2 pi over 3 and I add pi over 2, I'm going to get to 7 pi over 6. So looking at this, of course I need a common denominator here, so I would multiply this by 2 over 2. That would be 4 pi over 6, and then plus 3 pi over 6, which would be that 7 pi over 6 that I just saw on the graph. So let me come down here, and let me say, for the first quarter point, we have 7 pi over 6 for the x value. Again, for the y value, I'll show you how to get that in a moment. That's very, very simple to get. Let's go back up. Essentially, at this point, you're just going to keep adding quarter periods. So now I'm going to go 7 pi over 6 plus a quarter period. And again, now that I have a common denominator, it's going to be very, very easy. I'm going to go 3 pi over 6 here, and that's going to be 10 pi over 6. And of course, that's 5 pi over 3 if you simplify. So this is 5 pi over 3. And going to the graph, again, just look at the x value for this point, 5 pi over 3. So let's keep this as 10 pi over 6 so we have a common denominator. So 10 pi over 6 plus 3 pi over 6. This is 13 pi over 6. So for the 3/4 point, let me make this one better here. This would be 13 pi over 6. And coming down, again, 3/4 of the way, you have 13 pi over 6 for the x value. Again, all we're trying to do at first is find the x value here, the x value here, and the x value here. We don't care about the y values because those are easy to find. Now, coming back up, we also need to find the phase shift and the vertical shift, but I'll do that at the end. Coming back to this right here, again, notice that this is negative pi over 4, and this is negative 1. So negative pi over 4 for the x value, negative 1 for the y value, and your basic y equals the tangent of x. Then here it's 0, 0, and here it's pi over 4, 1. So notice that when we plug in, you're going to end up with the tangent of negative pi over 4, and you're going to multiply 2 by that, and then you're going to subtract away 2. So in other words, this original y coordinate of negative 1 is going to get multiplied by 2 first, and then we're going to subtract away 2 second. So this is 1 and this is 2. It just follows the order of operations. It's very easy to do. In other words, if you start with negative 1 and you multiply by 2, and then you subtract away 2, so negative 1 times 2 is negative 2, and then minus 2, so this becomes negative 4. You go down to the graph, you have 7 pi over 6 comma negative 4. So let me put that in there. Alternatively, if you get confused by that, which is fine, some people do, you can always plug in. So you can say f of 7 pi over 6 is equal to 2 times the tangent of, for this, you have x over 2. So you can say that that is 7 pi over 6, which is your x value, times a half. That would be 7 pi over 12. And then minus, you have 5 pi over 6. You can write that with a common denominator by multiplying by 2 over 2. So you can say that's 10 pi over 12. Close that down and then say minus 2. Let me slide down here a little bit. So 7 pi over 12 minus 10 pi over 12, that is going to be negative 3 pi over 12. So notice that that simplifies to negative pi over 4. And again, we know that the tangent of negative pi over 4 is negative 1. So this becomes 2 times -1 minus 2. That's just what we did, just looking at the graphing transformations of multiplying by 2 first and then subtracting away 2 just based on that original y coordinate of -1. It's much faster than plugging in. You get the same thing. So 2 times -1 is -2. And then minus 2, that's -4. So whichever way you want to do it, if you want to plug in, that's fine. If you don't, again, just memorize these y coordinates. So -1, 0, and 1. And then when you're looking at this guy, all you're doing is you're thinking about what's happening in terms of the vertical transformations. We have a vertical stretch by a factor of 2. In other words, you're multiplying your y coordinate by 2. So if it's -1, well, it's -1 times 2, that's -2. And then you have a shift down by 2. So if you now have -2 and you subtract away 2, now you're at -4. If you do it for the other two y values, for the midway, you have 0. So 0 times 2 and then minus 2. 0 times anything is 0. So then basically you just have minus 2, that's -2. Then the other one was 1. So 1 times 2 minus 2. So 1 times 2 is 2. 2 minus 2 is 0. So for the midway, you can have a y value of -2. And for 3/4, you can have 0. So this is -2. And then this is 0. Again, if you check this on the graph, here's 7 pi over 6 comma -4. Here's 5 pi over 3 comma -2. And then here's 13 pi over 6 comma 0. So you can see that matches up exactly with what we have on the graph. Again, if you want to get a little bit more practice, you can click the link I gave you for Desmos. You can get points over here or over here. I'll let you do those on your own. To finish things up, and this is going to lead into the next method, I'm going to do this problem again. We wanted to give the phase shift and also the vertical shift. The vertical shift is easy. It's just -2. Let me write that. So the vertical shift, you can just put down 2. And then the phase shift, this is the one that's tricky for a lot of people. You want to factor this. So you have f of x is equal to, you have 2 tangent of, let me move this over here like this. I'm going to pull out the coefficient of x. So it's 1/2, so pull that out. So inside, you would have x here. Now, this is where everyone gets tripped up. If I want to undo multiplication by 1/2, how do I do that? Well, I multiply by 2. So I want to put minus, I'm going to put 5 pi over 6 times 2 like this, and then cancel this with this and put a 3 down there. And then that's what you're going to want for your factorization. 1/2 times x is 1/2 x, or x over 2, then minus and minus, and then 1/2 times 5 pi over 3 would be 5 pi over 6. Close that down, and then minus 2. So what's the phase shift? You have this minus 5 pi over 3. Again, when you work on the inside of the function, you want to do the opposite. So if it's minus 5 pi over 3, how do I undo that? I need to add 5 pi over 3. So you would say you're going to go to the right 5 pi over 3. All right, for those of you that want to see this, I'm going to restart the problem and use only graphing transformations. So I'm not going to use that method where we use the quarter period to find the x values that we want. So we have f of x equals 2 tangent of x over 2 minus 5 pi over 6, then minus 2. So as we did a moment ago, we're just going to factor this. So we have f of x is equal to 2 tangent of, I'm going to pull out a 1/2. And again, we just saw this. So this becomes x minus 5 pi over 3. Again, you could pause the video and check if you need to, and then close this down, and then minus 2. So when we put this in factored form, it makes it easier to think about the horizontal transformations. The vertical ones are very easy. We saw that earlier, that this right here would be done first, and this right here would be done second. This is a vertical stretch by a factor of 2. This is a shift down by 2. This is done first. This is done second. It follows the order of operations. When I do some plugging in, you'll see why this is the case. Let me slide down here a little bit, and I'm just going to put, in terms of y, what you want to do first is multiply by 2. And then second, you want to subtract away 2, or you could say add -2. So we're just going to put subtract 2. So we already know this. We did this one earlier. Let me put a little border here. The ones for x, this is where it gets a little bit tricky and where students often make mistakes. The first thing is you have to think about, how can I undo what's being done to x? So everything is going to be undoing something, and also you have to go in the reverse order. When I plug in the end, I'll show you why that makes sense. But for right now, we want to look at this operation here. This is 1/2 times the quantity x minus 5 pi over 3. So using the order of operations, this right here would be done first. So if I plugged in something for x, I would subtract away 5 pi over 3 first, then I would multiply by 1/2. And I know you could distribute this in, but just looking at it in its current form without doing any distributing, this is how we would do it. This first, then this second. So if you want to undo that, you have to go in the reverse order. So this would be done first, and then this would be done second. And everything is us looking at how we can undo what's being done. So if I have multiplication by a half, to undo that, you need to multiply by 2. So here, you want to multiply by 2. So that's giving me a horizontal stretch by a factor of 2. Then this right here is minus 5 pi over 3. So how do I undo that? I need to add 5 pi over 3. So let me go for 2. We're going to add 5 pi over 3. So this would give me a shift to the right by 5 pi over 3. So let me paste this in right here. And again, if you're setting this up, you just need to know your 2 vertical asymptotes and your 3 key points. So coming back up, just to remind us, we look at y equals the tangent of x, where x is greater than negative pi over 2 and less than pi over 2. So a vertical asymptote at x equals negative pi over 2. Then you have the 3 points. So the first quarter point, negative pi over 4 comma negative 1. The halfway point is 0 comma 0. And the 3/4 of the way point, that's pi over 4 comma 1. And then you have a vertical asymptote at x equals pi over 2. So this is something you should have memorized. So let's come down here and let's do the points first. So if we have our first quarter point, then halfway, and then 3/4 of the way. Again, we already know that we have negative pi over 4 comma negative 1. We have 0 comma 0. And then we have our pi over 4 comma 1. So when we do our transformations, we are going to take our x value here, which is negative pi over 4. So negative pi over 4, and we're going to multiply by 2, and then we're going to add 5 pi over 3. So this would be equal to what? This right here would cancel with this right here and leave me with a 2 down there. So you'd have negative pi over 2, and let's multiply this by 3 over 3, so we can have a common denominator, and then plus you have 5 pi over 3. I'm going to multiply this by 2 over 2. The LCD there would be 6. So let's say this is equal to, you'd have negative 3 pi over 6, and then plus, this would be 10 pi over 6. So 10 pi over 6. And if you do the addition here, 10 pi plus negative 3 pi, that's going to be 7 pi. So you'd have 7 pi over 6. So 7 pi over 6. And for those of you that watched the first part where I did this using the quarter periods, you know that that was the x value for a quarter of the way through. So let's put a comma here. Let's get the y value. So that one's a lot easier. Again, all you're going to do for this is you're going to multiply by 2, then subtract away 2. So you take negative 1, you multiply by 2, then you subtract away 2. So this becomes negative 2 minus 2, which is negative 4. So that one's really easy. Okay, so for the next one, halfway, we have 0 comma 0. So this is really easy to work with. So for x, you multiply by 2, you'd still have 0. Then you add 5 pi over 3. That's 5 pi over 3. And then for this one, 0, if I multiply that by 2, I still have 0. Then subtract away 2, you have negative 2. All right, for this one, we have pi over 4 for the x value. So pi over 4. We want to multiply this by 2 first, and then add 5 pi over 3. So this would cancel with this and give me a 2 down there. So you're going to have, let's write pi over 2 as 3 pi over 6. So we can have a common denominator. And then plus, let's write 5 pi over 3 as 10 pi over 6. And this would be 13 pi over 6. So this is 13 pi over 6, and then comma. Again, for the y value, all you're doing is multiplying by 2 first and then subtracting away 2. So you're going to have 1 times 2, then minus 2. So this becomes 2 minus 2, which is 0. So this is 0 right there. Again, if we go back to the graph, we can verify these 3 points. So 7 pi over 6 comma negative 4, that's a quarter of the way. 5 pi over 3 comma negative 2, that's halfway. And then 13 pi over 6 comma 0, that's 3/4 of the way. So on the graph, you can see 7 pi over 6 comma negative 4, 5 pi over 3 comma negative 2, and then 13 pi over 6 comma 0. So we got our 3 points. Again, just using graphing transformations. Let me show you how to get the asymptotes here. So for that, you just need to do the transformations for x. So let me put a little border here. And from our model, we know that we start with x equals negative pi over 2. So negative pi over 2, you're just going to multiply by 2 and then add 5 pi over 3. So we see that this right here would cancel. So you have negative pi. You want a common denominator, so let's write that as negative 3 pi over 3. Just multiplying negative pi by 3 over 3, and then plus 5 pi over 3. And that's going to give you 2 pi over 3. So one of your asymptotes, when you talk about finding 2 consecutive vertical asymptotes, it's going to be at 2 pi over 3. So let's put for the vertical asymptotes, we get x is equal to 2 pi over 3. And then the other one, you'd have pi over 2. Again, you multiply by 2, and then you're going to add 5 pi over 3. So this would cancel. So you're going to end up with, let's say pi. You could write that as 3 pi over 3, and then plus 5 pi over 3. So that's 8 pi over 3. So the other one would be at, let's say, and x equals 8 pi over 3. Again, coming back to the graph, here's your x equals 2 pi over 3. Here's your x equals 8 pi over 3. Now, if you're trying to go to the right or to the left to extend the graph, all you have to do is use your period. You don't really have to use the quarter period, although you can use that if you want. The period here we found was 2 pi. So all you'd have to do is say, if I take this x value right here, which is 7 pi over 6, and I add 2 pi, well, I could add 12 pi over 6. That would be 19 pi over 6. So if I go over here, this point, let's say about right there, it's not going to be perfect, but let's say that this one would end up being 19 pi over 6, and then comma, the y value would be -4. And you can do the same process for this point and this point. You could add 2 pi to this x value to get over here. If you wanted to subtract away 2 pi from this x value, you'd go over there. The y value, again, for each quarter point is going to be the same. The y value for each halfway point is the same, and the y value for each 3/4 of the way point is going to be the same. So you don't have to worry about finding the y value. Let's take one of these points, and let's see if we can figure out why we got this multiply by 2 first, and then add 5 pi over 3. It's one thing for me to just tell you what the procedure is. It's another to stop and think about where it comes from. So let's go back up. And let's come to this guy right here. Now you can do this with any of the points. In terms of the y values, let me actually do that one first. If you think about why do we multiply by 2 and then subtract away 2 from whatever we get, if you plugged in a 7 pi over 6, so f of 7 pi over 6, and I'll actually show you what's going on in a moment. For right now I'm doing the y stuff, so let's just say this is equal to, you would end up with 2 times the tangent of negative pi over 4 and then minus 2. If you did f of 5 pi over 3, you'd get 2 times the tangent of 0 and then minus 2. If you did f of 13 pi over 6, you would get 2 times the tangent of pi over 4 and then minus 2. So notice that for the x value that's 1/4 of the way through, you end up with tangent of negative pi over 4. For the x value that's halfway through, you end up with tangent of 0. For the x value that's 3/4 of the way through, you end up with tangent of pi over 4. Again, just thinking about what's happening to y, we know the tangent of negative pi over 4 is going to be -1. That's a point on this model that we're using. We know the tangent of 0 is 0. We know the tangent of pi over 4 is 1. So the shortcut here, when you're using graphing transformations and not going through and plugging things in, you just need to memorize -1, 0, and 1. That way, when you think about it, well, I could really replace this with -1. So I could replace this with -1. I could replace this with 0. And then I could replace this with +1. So notice that all you're really doing here is you're saying, and let me put a multiplication symbol in here just so it's crystal clear what's going on. You're taking your y values that you've memorized, and then you're multiplying by 2. That's giving you that vertical stretch by a factor of 2. And then you're subtracting away 2 when you're done to shift down by 2 units. So 2 times -1 is -2, then minus 2, that's -4. Then 2 times 0 is 0, 0 minus 2 is -2. Then 2 times 1 is 2, then minus 2, that's going to give you 0. So that's the insight into why this works in terms of the y values. All you have to do is memorize -1, 0, and 1, because once you've found your x value for 1/4 of the way through, this is going to end up, this part right here, that's going to end up being -1. So all I have to do is multiply 2 times that -1 and then subtract away 2. This part right here would end up being 0 here, and then it would be 1 here. Okay, so now that we understand what's going on with y, let's talk about x. So this is the one that's quite confusing for people. You might need to plug this in multiple times. So I'm just going to do it with this first one, and I'll let you do the other ones on your own. So if I do f of 7 pi over 6, I want you to see what's being done to x, and then you got to think about how can I undo that. So this is 2 times the tangent of, we're going to plug in, so we have 1/2 times. For x, we want to put 7 pi over 6, and then minus, you have 5 pi over 3. You could write that as 10 pi over 6. So you have a common denominator, close that down, and then let's close this down, and then minus 2. Okay, so let's go in order. If we don't distribute this, and we're just using our order of operations, the first thing you would do to this x value of 7 pi over 6, you would subtract away 10 pi over 6. So that's the first thing. So the first thing we would do is we would subtract, and I'm going to write 5 pi over 3. That's the simplified version of 10 pi over 6. So when you do that, what do you get? So this equals 2 times the tangent of, you have 1/2 times 7 pi minus 10 pi, that's -3 pi. So this is -3 pi over 6. Close that down, close that down. Now -3 pi over 6 is -pi over 2. So then we have our minus 2 here. So what's the next thing we would do? we would multiply by a half. So let me put for number 2 here, we would multiply by 1/2. And if we do that operation, 1/2 times negative pi over 2, well, that's going to be negative pi over 4. So 2 times the tangent of negative pi over 4, close that down, and then minus 2. So again, going back to the model, we memorize the fact that a quarter of the way through, the x value is negative pi over 4. So what I have to do is actually undo what was done to x. Because if I plug in 7 pi over 6, I do some operations to it, and I end up with negative pi over 4. Well, if I'm only using graphing transformations, I don't know the 7 pi over 6. I know the negative pi over 4. So I have to go in reverse to get this right here. So hopefully that makes sense. Let me put a little border here, and let me put, how do we go in reverse? So this is what we want to do. Let me make this E better here. Okay, let me move this up a little bit so I can try to fit this on the screen. So the first thing here to undo what was done to x, you cannot start by undoing 1. You have to undo the latest thing that was done. You're going in reverse. So in other words, right now I have negative pi over 4. What I want to do is undo the multiplication by a half that got me to negative pi over 4. At this point I had negative pi over 2, and I multiplied by a half. Well, to undo that, I need to multiply by 2. So I need to multiply by 2. Again, going back to what we said in our procedure, notice that we multiplied by 2 first. So if I show this, we would have negative pi over 4, and then you're going to multiply by 2. And so this is going to cancel with this, and that gets you back to negative pi over 2. So that puts me back to this point right here. The next thing I want to do is undo this. What did I do here? I took 7 pi over 6, and I subtracted away 5 pi over 3, or you could say 10 pi over 6 if you want a common denominator. So now I need to undo subtraction by 5 pi over 3. So I'm going to add 5 pi over 3 to undo that. And so we come over here and we say, well, if we had negative pi over 2 and we added 5 pi over 3, again, you would need a common denominator, and I'm running out of space. So let me just do this here. Let's say that this is negative 3 pi over 6, and let's say that this is 10 pi over 6. Well, that gets me back to 7 pi over 6 right there. So you see that you need to undo each thing, and you have to go in the reverse order. That's why when you look at this guy right here, you're thinking about, how do I undo what's being done to x? Again, with the order of operations, this is done first. Think about when you plugged in 7 pi over 6, well, you subtracted away first. So now this is going to be last, and you have to do the opposite operation. So this is done second, and you're going to add 5 pi over 3. Then this right here, this would have been done second. So now when you're undoing things, you have to do this first, and you have to do the opposite operation. So you have to multiply by 2. So hopefully that makes sense for you. I know the first few times you go through graphing transformations in extreme detail, it gets quite confusing, but all you have to do is keep plugging in and going through the steps on your own. So start with something like, you could do 5 pi over 3, or you could do 13 pi over 6 if you want to do that on your own. Plug it in and go through each step, and then just say, well, how would I reverse that? In each case, you're going to come up with, okay, we need to multiply by 2 first, and then add 5 pi over 3. So the idea is I can start with negative pi over 4, something that I know, so something that would be right there, and I can undo all the steps, and then I would get back to 7 pi over 6, and that would be my x-coordinate for what I'm working with. All right, let's take a look at problem 2. So this is another one where I'll do it twice, once using the approach used in most textbooks, where we're involving the quarter period, and then I'll do it again, just using only graphing transformations, just so you can see that one more time, and then you can just pick the method that you like. We have f of x equals 3 tangent of 2x plus 5 pi over 3, then minus 2. So the first thing is I'm going to take this argument for the tangent function. So the 2x plus 5 pi over 3. This is greater than negative pi over 2 and less than pi over 2. So the least common denominator here is going to be 6 because you have 2, 3, and 2 for the denominators. So just multiply everything by 6. That way we can clear all those fractions. And so let's go through and say that this would be a 3 here. And then this right here would be a 2 here. And this right here would be a 3 here. So sliding down, you're going to have negative pi times 3, that's negative 3 pi. This is less than 6 times 2x is 12x. And then plus 2 times 5 pi is 10 pi, which is less than 3 times pi is 3 pi. So if I'm trying to isolate x in the middle, what I'm going to do is subtract 10 pi away from each part here. This is going to cancel. We have 12x is greater than negative 3 pi minus 10 pi, that's negative 13 pi, and it's less than 3 pi minus 10 pi is negative 7 pi. So if you want to isolate x in the middle, let's divide each part by 12. And so this would cancel, and you're going to get that x is greater than negative 13 pi over 12 and less than negative 7 pi over 12. Okay, let me paste this in. So for the two consecutive vertical asymptotes, you could say x is equal to negative 13 pi over 12. And then we're going to go x is equal to negative 7 pi over 12. All right, again, this is one that's pretty hard to see. I gave you that link on Desmos, so you can just click on that. This is your x equals negative 13 pi over 12. And this right here is your x equals negative 7 pi over 12. So those are your two consecutive vertical asymptotes. We need to figure out this point, this point, and this point. Really hard to read this because of the scale I had to use to get everything in here. But let's go back up. I'm just going to factor this now because we're going to need it in a moment. So f of x equals 3 tangent of, pull out the 2. So inside you'd have x plus, again, if I pulled out a 2, how do I undo multiplication by 2? Well, I need to divide by 2 or multiply by half. So you can go 5 pi over 3 times 2, which is 6. In other words, when this gets multiplied here, 2 times 5 pi over 6 is going to put me back to 5 pi over 3. It's just like I did this. I know a lot of people get confused by that. So this would end up being 5 pi over 6 there. So just close that down like that. And again, you could just check it to make sure. 2 times x is 2x. You have a plus and a plus. 2 times 5 pi over 6 is 5 pi over 3. So you're good to go. Then you have minus 2. For the phase shift, again, you're looking at, you have x plus 5 pi over 6. So that means I need to go to the left by 5 pi over 6. So let me write that in here. So for the phase shift, we're going to go left 5 pi over 6. We also need the vertical shift, and that's just going to be down by 2 because you have that minus 2 outside. So let's put down 2. Maybe that W could be better. Now for the period, again, the standard period for tangent is pi, and here you have this 2, right? You could think about it as being this guy outside the parentheses when it's factored, or the coefficient of x when it's not. So pi over 2 is going to be your period. So let's come down here and say that the period is pi over 2, and then the quarter period is going to be pi over 2 times a fourth, which is pi over 8. Okay, let me make this better here. So now, let me do this and do this. You're basically going to take this negative 13 pi over 12 and add a quarter period to get your x value for the first quarter point. Let me actually do this on another page. So negative 13 pi over 12. Let me make that better. And the quarter period is pi over 8. Again, getting a common denominator is what slows you down here. So if you have 12 and you have 8, again, 12 is 2 times 2 times 3, 8 is 2 cubed. So the LCD is going to be 8 times 3, which is 24. So I'm going to multiply this by 3 over 3, and I'm going to multiply this by 2 over 2. Let me slide this down like this. So this would end up being negative 26 pi over 24, plus this would be 3 pi over 24. So this would be negative 23 pi over 24. So when we think about our quarter period, we're just going to write it as 3 pi over 24 so we can have a common denominator. So let me just write these all at once and we'll go down and fill them out. Or actually, we can just keep it over here. This is a perfect page to use. So let me do this one and I'll just put a little border and I'll say for the 1/4 point or 1/4 point, if you want to say it that way, we'll say that the x value is negative 23 pi over 24. Let me go halfway and then 3/4 like that. So we're just going to keep adding quarter periods. Again, we're going to write this instead of pi over 8 as 3 pi over 24. So 3 pi over 24. So this would be equal to negative 23 pi plus 3 pi. That would be negative 20 pi over 24. And you can simplify that. So we would have a negative there. 20 divided by 4 would be 5. So this would be 5 pi over 24 divided by 4 is 6. So this is negative 5 pi over 6. And then again, you're just going to add a quarter period. So let me say this is negative 20 pi over 24, and then plus 3 pi over 24. So that's again our pi over 8 written with a common denominator. So this is going to be negative 17 pi over 24. Negative 17 pi over 24. Okay, let's get rid of this. And again, if you want your y values, you're going to come back up here and you're going to think about this is going to be done first, and this is going to be done second. So this is a vertical stretch by a factor of 3, and then you have a shift down by 2. So in other words, if you start with your points from the basic tangent function, so negative pi over 4, comma negative 1, and then 0, comma 0, and then you'd have pi over 4, comma 1, where you're going to take negative 1, multiply by 3, that's negative 3, and then subtract away 2, that's negative 5. Let me come down here. We don't need a border anymore. This one would be negative 5 for the y value. Then for this one, you have 0 times 3, that's 0. Then minus 2, that's negative 2. So this would be negative 2 for the y value. And then lastly, you would have 1 times 3, that's 3. And then minus 2, that's going to be 1. So this would be 1 here. So coming down here, again, just click that link on Desmos. This is going to be really hard to see. But for the first quarter point, you'll see that we do have negative 23 pi over 24, comma negative 5. You'll just have to trust me if you can't read it. Again, on Desmos, you can see it very clearly. Then for the halfway, you have negative 5 pi over 6, comma negative 2. So just matching that. And then 3/4 of the way, you have your negative 17 pi over 24, comma 1. So everything matches there. Again, if you want to get some extra practice and just get some points going to the right or to the left, I have things filled out for you going this way and this way. So one cycle to the right and one cycle to the left if you want to get some practice. All right, so I'm just going to do this one more time where I do the graphing transformations approach. A lot of students find this quite easy and quick. So if you're not making mistakes on the horizontal transformations, it's pretty much the way to do it. So you have to think about what's happening on the outside. So what's affecting the y. So again, we already looked at this. This is 1 and then this is 2. You follow the order of operations. You're multiplying by 3, so that's giving you a vertical stretch by a factor of 3. And then once that's done, you're subtracting away 2. That's shifting you down by 2 units. So for the y, we would just say that for part 1, we're going to multiply by 3. And then the second thing is going to be subtract 2, or you could put add negative 2 if you want. So that's the way you want to do that. Now in terms of x, again, this is where things get tricky. I've already factored it, so that makes it easier. But essentially, you've got to reverse the order and reverse what's being done. So normally, again, you work inside of parentheses first, and then you would multiply. That's the order of operations. You start with parentheses, but you've got to reverse that order. So you're going to do this 1 and this 2. What we're saying is that this is not multiplication by 2. It's going to be multiplication by a half or division by 2. So how do you undo multiplication by 2? You divide by 2 or you multiply by half. So some people will say that this is horizontally compressed by a factor of 2, and then other people will say that it's been horizontally shrunk by a factor of a half. I personally do not care how you say it. Just realize that you're taking the x value and you're either dividing it by 2 or you're multiplying it by a half. So let me just put here that we're going to multiply by 1/2. So each x value gets multiplied by half or divided by 2 if you want to do it that way. Then the second thing is, again, you've got to undo this. I'm adding 5 pi over 6. I've got to undo that. So I need to subtract. Let me put this u better here. Subtract 5 pi over 6. Always the opposite on the inside. It's the opposite order and everything needs to be undone. So just remember that. Okay, let me paste this in here and let me just start with the asymptotes. So you have your x equals negative pi over 2. And again, you just follow this. So you're going to multiply by half. So for the first part, you would say negative pi over 2 times 1/2. That gives you negative pi over 4. Then the second thing is you're going to subtract away 5 pi over 6. So you have negative pi over 4 and then minus 5 pi over 6. So the LCD there, you have 4, which is 2 squared, and you have 6, which is 2 times 3. So you need 4 times 3 or 12. So this becomes negative 3 pi over 12, just multiplying this by 3 over 3, minus this would become 10 pi over 12, multiplying this by 2 over 2. So you end up with negative 13 pi over 12. Again, going back to what we previously looked at, the vertical asymptote, you get x equals negative 13 pi over 12. So the same thing. So that is a vertical asymptote. Then you'd have your quarter point, you'd have your halfway, and then your 3/4. Then we need our other vertical asymptote. So we would work with pi over 2. So pi over 2, first you'd multiply by a half. Again, that's going to give me pi over 4. Then you want to subtract away 5 pi over 6. So pi over 4 minus 5 pi over 6. This becomes 3 pi over 12 minus 10 pi over 12. Again, multiplying this by 3 over 3 and multiplying this by 2 over 2. So this becomes negative 7 pi over 12. So let me get rid of that and just say that x equals negative 7 pi over 12. That would be our other vertical asymptote that we're finding. So let me put that this is our vertical asymptote. Again, coming back up, x equals negative 7 pi over 12. In terms of the points, let's go through those real quick. And let's just do the x part first, because it's a little bit more challenging. So you're going to take your standard points, which you have negative pi over 4, comma negative 1. So you take negative pi over 4, and you multiply by a half, and that gives you negative pi over 8. Then you have to subtract away 5 pi over 6. So negative pi over 8, and you subtract 5 pi over 6. Again, the tedious thing here is just getting common denominators. So you have 8, which is 2 cubed, and 6, which is 3 times 2. So you're going to want 8 times 3, which is 24. So multiply this by 4 over 4, and this by 3 over 3. Let me bring this down here. I'm going to run out of room. This would be negative 3 pi over 24 minus 20 pi over 24, which would be negative 23 pi over 24. So negative 23 pi over 24. For halfway, you're going to have an x value of 0. So that one's really easy to work with. You would want to do multiplication by a half. That would still be 0. And then subtract away 5 pi over 6. So that's minus 5 pi over 6. Then for 3/4 of the way, you have that pi over 4 comma 1. So you're going to go pi over 4 times a half. So that's pi over 8. So now you have pi over 8, and you want to subtract 5 pi over 6. Again, the LCD there would be 24. So let's say this is 3 pi over 24. Let me make that better. Minus, this would be 20 pi over 24. So multiply this by 3 over 3 and this by 4 over 4. So this would give me negative 17 pi over 24. And now we have negative 17 pi over 24. Okay, so that's done. So now we're working over here with the y values. You can just get rid of this. You don't need it. So you have, for the quarter of the way through, negative pi over 4 comma negative 1. So negative 1 times 3 is negative 3, and then minus 2 would be negative 5. And then you have 0 comma 0. So 0 times 3 is 0. Then minus 2 is negative 2.
And then you have pi over 4 comma 1. So 1 times 3 is 3. And then minus 2 is going to be 1.
I'll just come back up so you can compare them. You have your negative 23 pi over 24 comma negative 5, your negative 5 pi over 6 comma negative 2, and your negative 17 pi over 24 comma 1.
All right, let's take a look at problem 3. So for the rest of these, I'll just tell you that I'm just going to follow the book procedure. So we'll be using the quarter periods to get our x values, and we'll use graphing transformations to find the y values. So here we have f of x equals 4, tangent of 2x plus pi over 3 plus 2. Now, the first thing I'm going to do here, before I get any points or anything like that, I'm just going to go ahead and find the phase shift, the vertical shift, the period, and the quarter period. Just get that out of the way. So let's factor this. So f of x is equal to 4, and then tangent of. So pull out the 2. Inside, you're going to have x plus, again, if I want to undo multiplication by 2, I can divide by 2 or multiply by a half. So what you would do is say it's pi over 3 times 1/2. So we know that's going to be pi over 6. So this is pi over 6. Close that down and close this down, and then plus 2. Again, you can always check this. If you're not sure, 2 times x is 2x. Then you have a plus and a plus. 2 times pi over 6 would be pi over 3. So that's good to go. So when you factor it, it makes finding the phase shift much easier. You're just looking at this right here and you're saying, okay, well, I have x plus pi over 6. So I need to undo that. I need to subtract away pi over 6. So that means for the phase shift, I'm going to go left pi over 6. The vertical shift is super easy. You just have that plus 2 there. So for the vertical shift, we just want to go up 2. So that's all we need there. All right, I'm just going to drop this stuff off here, and we'll come back later on and revisit that page. You can erase this form. You don't need it if you're not using graphing transformations to find the x values. Let me slide down here a little bit, and let's think about the period. So we have this 2 that's the coefficient of x. Remember that the standard period for tangent is pi, but if you have this 2 that's multiplying the x there, well, what you do is you take your pi and you divide by 2. So the period is just pi over 2. So just dividing by the coefficient of x. Again, in factored form, it would be outside of parentheses. Then the quarter period, all you're going to do here is multiply this by a 4th. So that would be pi over 8. And again, I'll just drop this off here just so we have a page with our information. And let's go back up. So now that we found all that stuff, let's just go through and find the 2 consecutive vertical asymptotes, and we'll get our 3 points that we need. So the first thing is you're going to take your argument. So this guy right here. So the 2x plus pi over 3,
So let me set that up. So 2x plus pi over 3. And we're going to say it's greater than negative pi over 2 and less than pi over 2. If you want, you can clear the fractions or you can work with them. It's up to you. I think fractions are very tedious to work with, so I always clear them. So you have a denominator of 2, a denominator of 3, and a denominator of 2. So the least common denominator would be 6. So I'm going to multiply this by 6. And I don't know if I have room. Let me slide this over. So multiply this by 6. Let me move that down. And then multiply this by 6 and this by 6. Let me slide that over so it fits. We'll go through and just cancel some stuff. So 6 divided by 2 is 3. And then 6 divided by 3 is 2. And then 6 divided by 2 is 3. So if we go through, we would say that 3 times negative pi is negative 3 pi. And this is less than 2x times 6 is 12x. And then plus you have 2 pi there. And then this is less than 3 times pi is 3 pi. All right, let's subtract 2 pi away from each part here. So we'll cancel this, and we'll say that 12x is greater than negative 3 pi minus 2 pi, that's negative 5 pi. And we'll say this is less than 3 pi minus 2 pi, that's going to be pi. So all we need to do here is divide each part by 12 so that we can isolate x in the middle. So this right here. And so we'll see that this would cancel with this, and you get x is greater than negative 5 pi over 12 and less than pi over 12. So let's grab this and come down here and paste this in. So this is telling me that in terms of those two consecutive vertical asymptotes that I'm looking for, let me put v period a period. You're going to have one at x equals negative 5 pi over 12. And then we would say and. You have another one, x equals pi over 12. If you want to look at the graph real quick, again, I left you a link for Desmos. This is your x equals negative 5 pi over 12, that guy right there. And then this is your x equals pi over 12, so that guy right there. So now we just need this point, and this point. So how do we get that? Again, in terms of the x values, you could just start with this negative 5 pi over 12 and add quarter periods. Now, if you look at this being a 12 and this being an 8, again, you're going to need a common denominator. That's what makes this stuff so tedious. So think about 8, that's 2 cubed. Think about 12, it's 2 squared times 3. So really it's going to be 8 times 3, which is 24. So what you can do is multiply this now by 3 over 3 and say that we're going to write it as 3 pi over 24. It's just going to make your life a lot easier. So let's go ahead and say that we want negative 5 pi over 12 plus 3 pi over 24. And there's no room there, so we'll just do it here. And let me write this stuff up. So for the first quarter, halfway, and then 3/4. Let me set this up like this. So the x value for this first quarter would be done here. So let me multiply this by 2 over 2. That would give me negative 10 pi over 24, just getting a common denominator. So negative 10 pi plus 3 pi, that's going to give me negative 7 pi. And then this is over 24. So that's your x value there. So negative 7 pi over 24. And you're just going to keep adding quarter periods. So let's add 3 pi over 24. And what does that give me? Let me move this up here. So this would be negative 7 pi plus 3 pi. That's going to be negative 4 pi over 24. If you simplify that, if you divide 4 by 4, you get 1. So this would be negative pi over 24 divided by 4 is 6. So negative pi over 6. Now just keep it in this form right here. So you have a common denominator already. Let's just move this up like that. And for this guy right here, negative 4 pi over 24 plus 3 pi over 24, that's negative pi over 24. So negative pi over 24. How do we find the y values? Again, you could plug in, but that's super slow. So I would suggest using graphing transformations for these. Again, go back up and look at what you're doing. You have this guy out in front. So this is a 4 that's multiplying this guy. So the tangent of this right here. So this is giving me a vertical stretch by a factor of 4. This is done first. Then this guy is done second. This is a shift up by 2. So we're going to multiply by 4, and then we're going to add 2. And we're doing this to the y coordinates, again, from the basic tangent function that we're working with. So negative 1, 0, and 1. So let me bring this down here, and hopefully you can remember this. If not, you could write out the points. Let me just do that real quick. So negative pi over 4, comma negative 1, then you have 0, comma 0, and then you have pi over 4, comma 1. I know most of you have memorized this at this point, but you're going to take negative 1, multiply by 4, that's negative 4, then add 2, that's negative 2. Then you're going to take 0, multiply by 4, that's still 0, then add 2, so that's 2. Then you're going to take positive 1, multiply by 4, that's 4. Then add 2, that's going to be 6. All right, let's get rid of this. And the last thing to do here is you can just check these points. Again, you could just click that link and see, but I'm going to go down and just show this to you. So let me paste this in. And kind of hard to read, but again, if you start here at a quarter, you're going to have -7 pi over 24, comma -2. So that matches this. Then halfway, you're going to have -pi over 6, comma 2. So that matches this. And then 3/4, you have -pi over 24, comma 6. So that matches this. Again, click the link on Desmos. You'll see I gave you the points over here and over here. So one cycle to the right and to the left if you want to do some more practice. Okay, let's take a look at problem number 4 now. So we have our f of x equals -1/2 tangent of x plus pi over 2. In terms of the phase shift here, so the phase shift, I don't have to factor this. So I just have x plus pi over 2. So I think about how do I undo this plus pi over 2? Well, I've got to subtract away pi over 2. So we're going left pi over 2. In terms of the vertical shift, there's nothing out here. So that's none. So vertical shift, that is none. Okay, let's grab this, come down here, and I'm just going to paste that right here with our information. Come back up. Again, if you want to do the y coordinates first, you can, and just get out of the way. All you're really doing is multiplying each y coordinate by -1/2. So if you want to do that here, here's the 1/4, here's the half, and here's the 3/4. Well, again, normally at 1/4, the y value is -1, but you're going to multiply it by -1/2. So that means I'm going to get +1/2. Normally it's 0 here. 0 times anything is still going to be 0. And then normally it's 1 here. 1 times -1/2 is -1/2. So now let's go in and get the period. Notice that the coefficient here is 1. So it's just going to be the standard period of pi. So for the period, that is pi. And then for the quarter period, it's just pi over 4. Let's just focus on getting the x values now. So just take the inside part here, the argument, so x plus pi over 2. We're going to say, where is this greater than -pi over 2 and less than pi over 2? Well, the least common denominator here is 2 because you have a denominator of 2, 2, and 2. So just multiply each part by 2. Multiply by 2, and 2, and 2, and then 2. And that's going to give me -pi is less than 2x, and then plus this would be pi, which is less than this would be pi. And let me show things as canceling so nobody is lost. And let's make this x better. Now let's subtract pi away from each part. And so this would cancel. So we're going to have 2x in the middle. So we have 2x is greater than -pi minus pi is -2 pi. And it's less than pi minus pi is 0. Let's divide each part by 2. And so this is going to cancel. Let me slide down here and say that x is greater than, this 2 would cancel this 2, so this is -pi, and less than 0 over 2 is 0. Come down and paste this in. So when you think about your 2 consecutive vertical asymptotes, you're going to have vertical asymptotes, x is equal to -pi, and x is equal to 0. Coming down to look at the graph, here's your x is equal to -pi, and then here is your x is equal to 0. So again, when you have x equals 0, that's the y-axis, you typically do not draw in an asymptote because you already have something there. You can put it there if you want. It's not incorrect, but that's how I'm going to draw it. So we need to figure out this point, and this point. So let's go back up. Okay, so we know the quarter period is pi over 4. And we're starting with x equals -pi. That's the leftmost consecutive vertical asymptote. So you have -pi and then plus pi over 4. So you could write this as -4 pi over 4. And this would give you -3 pi over 4. So that's going to be for this one right here. So -3 pi over 4. And then you're just going to keep adding a quarter period. So you're going to go -3 pi over 4 and then plus your pi over 4. That would be -2 pi over 4. That's going to simplify to -pi over 2. So -pi over 2. And then again, you can take your -2 pi over 4 and add a quarter period. So we're going to add pi over 4. And that would be -pi over 4. So -pi over 4. And let's just check these points real quick and we'll be done. And let me paste these in. Here's quarter of the way through. You have -3 pi over 4 comma 1/2. Then halfway, you have -pi over 2 comma 0. 3/4 of the way, you have -pi over 4 comma -1/2. So again, those points are there. I've labeled these points and these points there for you. If you want to get some additional practice, just go ahead and click on that link and you can go to the left or to the right by one cycle or even more cycles if you want to play around with the graph. All right, let's look at problem 5. So this is the last problem with tangent. So f of x equals 1/4 tangent of x over 4 minus 2 pi over 3 plus 1. So I'm going to factor it first, just so we can get that information. So f of x equals 1/4. And then tangent of, pull out a 1/4 there. Inside, you're going to have x minus, again, if I'm pulling out a 1/4, how do I undo that? How do I undo multiplication by a fourth? You multiply by 4. So 4 times 2 pi would be 8 pi, and this is over 3. Close that down, and then plus 1. 1/4 times x is 1/4 x, or x over 4, minus and minus. 1/4 times 8 pi over 3, 8 divided by 4 is 2. So you'd have 2 pi over 3, which is what you have there. So this tells me that for the phase shift, I am going right, so I want right by 8 pi over 3. So 8 pi over 3. Again, this is minus 8 pi over 3. So to undo that, I need to add 8 pi over 3. Then my vertical shift, so my vertical shift is going to be up by 1. So up 1. And let me paste that in there so we have it. We also need the period, and we need the quarter period. So let's get that real quick. So again, in factored form, you have this guy right here, 1/4. If it's not in factored form, it's just going to be the coefficient of x. So you take your standard period, which is pi, and you divide by that. So what is pi divided by a fourth? In other words, I'm saying what is pi over 1 divided by a fourth? Well, that's pi over 1 times 4 over 1, which is 4 pi. So the period is 4 pi, and the quarter period is just pi. It's 4 pi over 4, which is just pi. Now, if you want to get your y values now, again, it's easy to do. You're going to multiply by a fourth, and then you're going to add 1. This 1/4 right here is giving you a vertical compression by a factor of 4. Again, some people will say it's vertically shrunk by a factor of a fourth. I don't care the terminology you use. Just realize that if you have a y value, you are either dividing by 4 or you're multiplying by a fourth. It has the same impact on that y coordinate. So that's what you're doing first. Then you're adding 1. So what I would do is take, again, you have -1, 0, and 1. So -1 times a fourth, and then plus 1. Then you can have 0 times a fourth, and then plus 1. Then you're going to have +1 times a fourth, and then plus 1. You might as well write this in each case. Well, not this one, because it's not going to matter. But this is 4 over 4, and this is 4 over 4, so you have a common denominator. So this would be -1/4 plus 4 over 4. So this would be 3/4. Then here, this would be 0 times anything is still 0. So 0 plus 1 is 1. And then here, 1 times a fourth is a fourth. And then plus 4 over 4, this is 5/4. So you get 3/4, 1, and 5/4. So let me put quarter, half, and 3/4. Put our points in there. So this is 3/4, 1, and 5/4. Let me make that better. Okay, so now we just need the x values. To do that, I'm going to go x over 4 minus 2 pi over 3 is greater than -pi over 2 and less than pi over 2. Now you have a denominator of 2, 4, 3, and 2. So really you want 4 times 3 or 12. That's going to be your LCD. So I'm going to multiply everything here by 12. Let me scooch this down and go 12 times this, and then times 12, and then times 12. All right, so 12 divided by 2 is 6. 12 divided by 4 is 3. And then 12 divided by 3 is 4. And then 12 divided by 2 is 6. So looking at this, we have 6 times -pi, that's -6 pi. This is less than, you have 3x, and then minus 2 pi times 4, that's going to be 8 pi. And this is less than, 6 times pi is 6 pi. So here, let's add 8 pi to each part. So this is going to cancel. We have 3x in the middle, and this is greater than -6 pi plus 8 pi, that's going to be 2 pi. And it's less than 6 pi plus 8 pi, that's 14 pi. Let's divide each part by 3. And let's come down here and say that this would cancel. So we're going to end up with x is greater than 2 pi over 3 and less than 14 pi over 3. Let me make this better here. Let me grab this and let me come down here and paste this in. So in terms of your vertical asymptotes, you have one at x equals 2 pi over 3. And then you have your x equals 14 pi over 3. So coming down to the graph, here is your x equals 2 pi over 3. And then here is your x equals 14 pi over 3. And we just need these points right here. So we already know the y value is 3/4, 1 5/4. We got that earlier. But we need to get these x values here. So let's go back up. So again, I'm just going to start with this. So 2 pi over 3 That's the x value from the leftmost vertical asymptote that we found. And I'm going to add a quarter period. So I'm going to add pi. You can write that as 3 pi over 3. So 2 pi over 3 plus 3 pi over 3, that's 5 pi over 3. Then you just keep adding 3 pi over 3. So now this would be 5 pi over 3 plus 3 pi over 3. That would be 8 pi over 3. And then do that one more time. So 8 pi over 3 plus 3 pi over 3. That would be 11 pi over 3. So these are going to be those 3 points right there. Let me just grab this real quick. Come down here and I'll just paste this in. So this point right here, you can see it's 5 pi over 3 comma 3/4. Then this point right here is 8 pi over 3 comma 1. And then this point right here is 11 pi over 3 comma 5/4. This is an example of one where you get these 3 points and it would still be hard to draw this by hand because you really don't have any guidance here other than I'm going to draw it to where I approach this asymptote, and the same thing goes over here. So if you want to get something a little bit further to the right, you could just pick something that's close to right here so you can get one of these points in here. It would help you if you were trying to make a more accurate graph by hand. But again, a lot of teachers don't care even in this scenario. You just put your vertical asymptote, your 3 points in your vertical asymptote, and just do the best you can to sketch it. Again, if you want to play around with this and get some additional points, I have this filled in for you for this cycle right here and this cycle right here on Desmos. Okay, the next problems will deal with the cotangent function. So again, I want to show you this one more time from the lesson. We graphed y equals cotangent of x, where we said that x was greater than 0 and less than pi. So for the cotangent of x, now you have the cosine of x over the sine of x. So this guy's going to be undefined anywhere where the sine values are 0. So that's at 0, pi, 2 pi, 3 pi, or you can go negative pi, negative 2 pi. So basically pi n where n is any integer. So you see you have a vertical asymptote. It's not shown, but it would be where x is 0. Again, if you have the y-axis there, you don't need to put it. Basically, this guy is drawn to where it approaches that, but doesn't touch it. And then you have one at pi. But again, you'd have one at 2 pi, 3 pi, 4 pi, so on and so forth. In terms of your points that you're going to use, you need to memorize that you have pi over 4 comma 1. So pi over 4 comma 1, that's a quarter of the way through. This one right here is going to be pi over 2 comma 0. And then this one right here is going to be 3 pi over 4 comma negative 1. So you need to memorize this for the quarter, halfway, 3/4. Very important to memorize those. Now, in terms of the period, it's still going to be pi. So if you get something like y equals the cotangent of bx, something like this, well, then the period is going to be pi over b, just like we saw with tangent. So pretty much everything is the same in terms of the process. You're just going to be solving this inequality here, where you take your argument and plug it in for x. That's going to get you started. That's going to give you your 2 consecutive vertical asymptotes. And then you just figure out what is the period, and you can add quarter periods to get your x values for your 3 key points. The y values, you can just still use graphing transformations. You just have to memorize these points here. The y value for a quarter of the way through is 1, then halfway through is 0, and then 3/4 of the way through is negative 1. All right, let's take a look at problem 6. So we have f of x equals 3, cotangent of x over 3 minus 5 pi over 6, and then plus 2. The first thing I'm going to do is just get the information. So f of x equals 3, cotangent of, let me just pull this out. So 1/3 times, you can have x and then minus. Again, I want to undo multiplication by 1/3. So that means I need a 3 here. So I'm going to go 3 times 5 pi over 6. This 3 would cancel with the 6 and give me a 2 down here. So let's put 5 pi over 2. So 5 pi over 2. And then close this down and then plus 2. So when you check this, 1/3 times x is 1/3 x, or x over 3. You have a minus and a minus. 1/3 times 5 pi over 2, that would be 5 pi over 6. So this is good to go. So I do this so I can get the phase shift. And so that's basically going to be your phase shift. You have minus 5 pi over 2 here. So you need to undo that by adding 5 pi over 2. So that means I'm going to the right 5 pi over 2. That's all it is. Let me fix that. And then the vertical shift, that is going to be, you have a plus 2 on the outside, so just up 2. So we also need the period in the quarter period. So again, for the period for cotangent, it's just pi. And you have this 1/3 that's right here, or again, you can think about it as, what's the coefficient of x? It's 1/3. So you just take pi and divide it by 1/3. That's the same thing as multiplying by 3. So your period would be 3 pi. So let's come down here and say that the period is 3 pi. And so the quarter period is going to be 3 pi divided by 4. So 3 pi over 4. Okay, so let me make this p better here, like this. And let me move this down a little bit so we have some room and come back up here. We don't really need the factored form anymore. Again, if you're going to do this with all graphing transformations, you can use it. Let me slide down here a little bit. I'm going to do the y's first, just easy to do. You're multiplying by 3. That's the first thing. And then the second thing is you're going to add 2. So you're going to multiply by 3. That's number 1. And then the second thing is add 2. Now remember, your points changed. Now you have pi over 4, comma 1. Then you have pi over 2, comma 0. And you have 3 pi over 4, comma negative 1. So you have to memorize these new points. If you're used to working with tangent, it's going to throw you off. So let me do this. And let me get the y values. Let me move this over here so it fits. Do this and this, comma, comma. Put that and that and that. Maybe that could be better. So multiply by 3. 1 times 3 is 3. Then add 2. 3 plus 2 is 5. So then 0 times 3 is 0. Plus 2 is 2. And then negative 1 times 3 is negative 3. And then plus 2, that's negative 1. And let me label this. So this is for the quarter, half, 3/4. And let me just put this in here. And basically, we just need the x values now. So let me come up here. And again, you can use graphing transformations if you want. I'm just going to stick with the book method. So I'm going to go x over 3 minus 5 pi over 6. Now you've got to go greater than 0 and less than pi. So what you're going to do here is find that the LCD is going to be 6. So just multiply everything by 6. So times 6, times 6, times 6, times 6. And 0 times 6 is going to be 0. So this is less than 6 divided by 3 is 2. 2 times x is 2x. And then minus the 6 is cancel. You get 5 pi. So which is less than 6 times pi is 6 pi. All right, so let me add 5 pi to each part here. This cancels. We get 2x is greater than 5 pi and less than 6 pi plus 5 pi, that's 11 pi. Let me divide each part here by 2. And so this is going to cancel. And we're going to get x is greater than 5 pi over 2 and less than 11 pi over 2. So let's grab this and we'll paste this in here. And now we have our 2 consecutive vertical asymptotes. So for the vertical asymptotes, you get x is equal to 5 pi over 2, and then x is equal to 11 pi over 2. So coming to the graph, here's your x equals 5 pi over 2. Here's your x equals 11 pi over 2. So we just need this point, and this point. We already know the y values. We just need to get the x values. So again, start with this x equals 5 pi over 2. That's the leftmost vertical asymptote that you found. So 5 pi over 2. And you're going to add a quarter period. So you're going to add 3 pi over 4. Let me do this on another page. Just multiply this by 2 over 2. And you're going to get 10 pi over 4. So this is 10 pi over 4 plus 3 pi over 4. That is 13 pi over 4. And then you just keep adding a quarter period. So you're going to have that 13 pi over 4 plus 3 pi over 4. That would give you 16 pi over 4. So this would be equal to 16 divided by 4 is 4, so this would be 4 pi. So let me put 4 pi here. Just keep this in this form so we have a common denominator. So keep it as 16 pi over 4. And add 3 pi over 4, so that's going to be 19 pi over 4. So 19 pi over 4. All right, so we have our points. Let's just check it real quick. So let's paste this in. So a quarter of the way, we should have 13 pi over 4 comma 5. So that's what we have. And then we have for halfway 4 pi comma 2. So that's what we have. And then 3/4 of the way, we should have 19 pi over 4 comma negative 1. So that's what we have. Again, just click the link on Desmos if you want to see things in more detail or practice going a cycle to the right or to the left. I already have those points filled in for you. All right, let's take a look at problem 7. So we have f of x equals 2 cotangent of x over 2 plus 5 pi over 4 and then minus 2. Let me slide down here a little bit. And I'm just going to start off with a phase shift. So we'll get that out of the way. So f of x is equal to 2 cotangent of. I'm just going to factor out a 1/2. So inside you'd have x plus. Again, if I want to undo multiplication by a half, what I can do is multiply by 2. So just take that 5 pi over 4. That's there right now. And multiply by 2. So this would cancel with this and give me a 2 down there. So this would be 5 pi over 2. Close that down, close this down, and then minus 2. again, you can always check 1/2 times x is 1/2 x, or you could say x over 2. Then you have plus and plus, and then 1/2 times 5 pi over 2 would be 5 pi over 4. So this is good to go. So when we think about the phase shift, again, we're focused on that part right there, and we want to undo that. So we would want to subtract away 5 pi over 2. So for the phase shift, we're going to go to the left by 5 pi over 2. In terms of the vertical shift, again, this one's always the easy one to get. We just have that minus 2 on the outside there. So let's say that the vertical shift is going to be down 2. Now, while we're here, we can just grab the period and quarter period. So what is the period? Again, just take the standard period for cotangent, which is pi, and you're going to divide by this guy right here, this 1/2. Again, if it's not in factored form, you'd see 1/2 x. So you're just looking at either the coefficient of x if it's in unfactored form, or the number outside of the parentheses when it's in factored form. So divide pi, your standard period for cotangent, by 1/2. That's going to be 2 pi. So the period is 2 pi, and then the quarter period, that's going to be 2 pi over 4, which I think we know at this point is pi over 2. And let me paste this in here. Okay, so once again, if you're not using horizontal graphing transformations, which we're not going to do here, you can erase this form. You don't really need it. I'm just going to stick to working with this. So I'm going to take this argument here, this x over 2 plus 5 pi over 4, and I'm just going to set up my inequality. So x over 2 plus 5 pi over 4, we'll say that's greater than 0 and less than pi. So here, the least common denominator would be 4, since you have a denominator of 4 and a denominator of 2. So let's multiply everything by 4, just so we can clear those fractions. And so this right here would cancel with this and give me a 2, and then this would cancel. And so what you have is 0 times 4, which is still 0. That's less than 2 times x is 2x, and then plus this cancels, so you just have 5 pi, and then this is less than 4 times pi is 4 pi. At this point, I'm going to subtract away 5 pi from each part. And so this right here is going to cancel. So you're going to have 2x is greater than 0 minus 5 pi is negative 5 pi. And it's going to be less than 4 pi minus 5 pi, that's negative pi. To finish things up, let's divide each part by 2. So we can isolate our x in the middle. So we want that right there. So this would cancel. You get x is greater than negative 5 pi over 2 and less than negative pi over 2. Okay, let me paste this in here. So your two consecutive vertical asymptotes, you're going to have x is equal to negative 5 pi over 2. And then I'm going to write and. You're going to have x is equal to negative pi over 2. Again, if you want to verify this on the graph at this point, here's your x equals negative 5 pi over 2. And then here's your x equals negative pi over 2. So we got that part. We need this guy, and this guy. So let's go back up. So the quarter period is pi over 2. So that's going to work out quite nicely for us. So we're just going to take this negative 5 pi over 2. So that's the leftmost consecutive vertical asymptote that we found. And we're going to add a quarter period. So plus pi over 2. Let me do this on another sheet. So let me paste this in here. So this would give me negative 4 pi over 2, which of course is going to simplify to negative 2 pi. So if I'm setting this up, you have your first quarter point, you have negative 2 pi, and then you have your halfway, and then you have your 3/4 of the way. And so now negative 4 pi over 2, that's the next one you're going to do. You're just going to keep adding quarter periods. So we're going to go plus pi over 2. So this is negative 3 pi over 2. So negative 3 pi over 2. And I want to do this one more time. So now let's go negative 3 pi over 2 and then plus pi over 2. That's going to give me negative 2 pi over 2, which is negative pi. So this is negative pi. All right, for the y values, again, it's very straightforward. Let's go back up. When you look at what you have for the vertical transformations, you have this 2 right here that's giving you a vertical stretch by a factor of 2. So first you're going to multiply by 2. And then the second thing you have here, you have a shift down by 2 units. This one right here is going to be subtract 2. So multiply by 2 first, then subtract away 2. Let me grab this and let me paste this in. So hopefully you remember the y coordinates. They've changed versus tangent, so a lot of people get them confused. But with cotangent, you're looking at 1, 0, and then negative 1. With tangent, it's negative 1, 0, and 1. So you just have to remember that. So you're starting with 1, you're going to multiply by 2, and then subtract away 2. So I'm going to go 1 times 2 minus 2. Then you'd have 0 times 2 minus 2. Then negative 1 times 2 minus 2. So 1 times 2 is 2. 2 minus 2 is 0. Close that down. 0 times 2 is 0. Minus 2 is negative 2. Close that down. Negative 1 times 2 is negative 2. Then negative 2 minus 2 is negative 4. So let's put negative 4. Close that down.
And again, we can just check this real quick and be done. All right, let me paste this in. For the first quarter point, you have negative 2 pi comma 0. So that's this guy right here. For the halfway, you have negative 3 pi over 2 comma negative 2. So this guy right here. And then for the 3/4 of the way, you have negative pi comma negative 4. So this guy right here. So once again, I did leave you a link on Desmos if you want to go to the left or right by one cycle or play around with the graph and get some more points going on your own. All right, let's move on to problem number 8. So here we have f of x equals 3, cotangent of x over 3 plus pi over 3 plus 2. I'm just going to get the phase shift out of the way. So let's go f of x is equal to 3, cotangent of, pull out a 1/3. Inside you'd have x plus pi. Close that down, close this down, then plus 2. So this one's really easy. A third times x is x over 3 or 1/3 x, then plus and plus. And then you have 1/3 times pi. That would be pi over 3 or 1/3 pi, if you want to write it that way. So that is a match. So the phase shift, again, I want to undo this. I have plus pi there, so I want to undo that by saying minus pi. So I'm going to the left by pi. So for the phase shift, I want to go left pi. Then when we think about the vertical shift, again, this plus 2 out here, that's just telling me I'm going up by 2 units. So for the vertical shift, we're just going up 2. You can erase this. You could keep it if you want. We just need the period and the quarter period. Again, the coefficient of x here is 1/3. So you're just taking that standard period, which is pi, and dividing it by 1/3. So that just means you're multiplying by 3. So you're going to get 3 pi. So the period here is going to be 3 pi. And so the quarter period is going to be 3 pi over 4. So that's all we need there. Let's grab this, come down here and paste this in and come back up. So what I'm going to do now is, again, just get my consecutive vertical asymptotes. I'm just going to grab this right here, this argument for the cotangent function, and just set up my inequality. So x over 3 plus pi over 3 is greater than 0 and less than pi. Let's multiply everything by 3 so we can clear these fractions and not have to work with them. So this is 0 is less than. This cancels, so you have x plus, this cancels. So you can have pi, which is less than. 3 times pi is 3 pi. So for this one, I'm just going to subtract pi away from each part here. This cancels. So we'll have that x is greater than. 0 minus pi is negative pi, and it's less than. 3 pi minus pi is 2 pi. Okay, let's grab this, and we're going to just paste this in. So the consecutive vertical asymptotes that we're finding, you get x is equal to negative pi, and you can have x is equal to 2 pi. Let's go down, and let's just check this real quick. So here's your x equals negative pi, and then here's your x equals 2 pi. So we need this point, and this point. So let's go back up and get those. So we're going to start with an x value of negative pi, and again, you're adding quarter periods, so 3 pi over 4. So let's do negative pi plus 3 pi over 4. You could just write this as negative 4 pi over 4. So you have a common denominator. So for the first quarter point, the x value would be negative pi over 4. Just doing negative 4 pi plus 3 pi, that's negative pi, and then over the common denominator of 4. So for the first quarter point, the x value is negative pi over 4. Let's do halfway, and then 3/4. So negative pi over 4, you would add 3 pi over 4, and that would give you 2 pi over 4, and that's going to simplify to pi over 2. So this is pi over 2. So let me erase this and put this now as 2 pi over 4. So I'm going to add 3 pi over 4, and that's going to give me 5 pi over 4. So that's for this one right here. Now again, in terms of getting the y values, we're just going to use graphing transformations. Let's go back up. You have this 3 right here. Again, that's a vertical stretch by a factor of 3. And then here you have this 2. So plus 2, that's giving me a shift up by 2. So again, the first thing here, you would multiply by 3. And then the second thing here, this is going to be, we're going to add 2. That's all it is. So multiply by 3 and then add 2. Okay, let me paste this in. So again, remembering your basic points, you're going to put a 1 here. So that's going to get multiplied by 3, and then you're going to add 2. Then you want a 0 here. Multiply by 3, then add 2. Then you want a negative 1 here. Multiply by 3, and then add 2. 1 times 3 is 3. 3 plus 2 is 5. So this is going to be a 5. 0 times 3 is 0, plus 2 is 2. So this is going to be a 2. Negative 1 times 3 is negative 3, plus 2, that's going to be negative 1. So let's grab this, and let's just paste this in maybe right there. And so this point right here, a quarter of the way through, again, you have negative pi over 4 comma 5, so that guy right there. Then halfway through, you have pi over 2 comma 2, so that guy right there. And then 3/4 of the way through, you have 5 pi over 4, comma negative 1. So right there. Again, click the link if you want to get more points on this side or this side. I have them filled out for you on Desmos. All right, let's take a look at problem 9. So here we have f of x is equal to 3 cotangent of 2x minus 5 pi over 6, and then plus 1. Let me slide down here a little bit. Again, I'll just start with the phase shift just to get it out of the way. So f of x is equal to 3 cotangent of. Let me pull out the 2 there. So inside you'd have x minus. Again, if I'm pulling out a 2, I need to think about how could I undo multiplication by 2, because when this comes back in, I'm multiplying by 2. To do that, I want to divide by 2 or multiply by a half. So what you're going to do is say this is 5 pi over 6 times a half. So that's really going to turn into 5 pi over 12. So that's what you want. Close that down, close this down, and then plus 1. Again, we'll just check it. So 2 times x is 2x. Then you have minus and minus. 2 times 5 pi over 12 would be 5 pi over 6. So that is good to go. So when you think about the phase shift, again, you have this minus 5 pi over 12. So I want to undo that. So I want to add 5 pi over 12. So I want to go for the phase shift to the right, 5 pi over 12. That 5 could be a lot better. Now, in terms of the vertical shift, again, it's just this plus 1 over here. So for the vertical shift, we're just going up 1. So very, very easy. Let me just paste this in right there. Again, if you want the period, you're going to take the standard period for cotangent, which is pi, and you would divide it by 2. Again, in this form, it's the coefficient of x. In this form, it's the number outside of the parentheses. So we just want to go for the period that it's pi over 2. And then for the quarter period, again, you're just going to take pi over 2, multiply by a fourth. That is pi over 8. You can erase this form. We don't need it since we're not using horizontal graphing transformations. Let's come down here and put this right there. And now let's find our 2 consecutive vertical asymptotes. So 2x minus 5 pi over 6 is greater than 0 and less than pi. So I just have one fraction and the denominator is 6. So let's multiply everything here by 6. And so you would have 0 times 6, which is still 0. Is less than 6 times 2x is 12x. Then minus this right here is going to cancel. So you're going to have 5 pi, which is less than 6 times pi is 6 pi. All right, let's add 5 pi to each part here. And so this is going to cancel. You have 12x is greater than 0 plus 5 pi is 5 pi. We'll say and it's less than 6 pi plus 5 pi is 11 pi. To finish things up and isolate x, what we're going to do is we're going to divide each part here by 12. And so this is going to cancel. So you have x is greater than 5 pi over 12 and less than 11 pi over 12. Okay, we can grab this now and we can paste this in. Let me put a little border here. So the 2 consecutive vertical asymptotes that we're looking for, let me put v period a period. We're going to have x equals 5 pi over 12. And then we're going to have x is equal to 11 pi over 12. Here's your x equals 5 pi over 12. So you have that guy right there. And then here's your x equals 11 pi over 12. So that guy right there. So we need this point, and this point. So coming back, I'm going to start again with this leftmost vertical asymptote that we found. So 5 pi over 12. And I'm going to add a quarter period. So plus pi over 8. What makes this also time consuming is just dealing with all these fractions and having to get common denominators. You should know at this point that if you're working with 8, which is 2 cubed, and you're working with 12, which is 2 squared times 3, the LCD is 8 times 3, which is 24. So I'm just going to multiply this by 3 over 3 and this by 2 over 2. So this becomes 10 pi over 24 plus 3 pi over 24. So this would give me 13 pi over 24. Now you would keep adding a quarter period. I would just write it as 3 pi over 24. So let me put for the first quarter point, the x value is 13 pi over 24. And then we need halfway and then 3/4. Put that up there. So you're going to keep adding, again, 3 pi over 24. That's just pi over 8 with a common denominator. So this would give me 16 pi over 24. Now if you want to simplify that, 16 divided by 8 is going to be 2, and 24 divided by 8 is 3. So this would be 2 pi over 3. And then I'm just going to keep it in this form. Let me erase this and move this over here, just so I have a common denominator. And then this would be 16 pi plus 3 pi. That's 19 pi, and then over 24. So this would be 19 pi over 24.
So not too bad. Let's go up and figure out what we need to do to y. So for this part right here, you are multiplying 3 by your cotangent function. And so that's giving me a vertical stretch by a factor of 3. So that part's going to be done first. So let's put that we're going to multiply by 3. Then you have your plus 1 here. So that's shifting me up by 1 unit. So that guy would be done second. So we'll say that we're going to add 1. So let's grab this and come back down here. So just remember your basic points, and you're taking the y values. So for this one, it's going to be 1, and then you're just going through this, so times 3, and then plus 1. Here it would be 0, and then again, you'd go times 3, and then plus 1. Here it would be negative 1, so then times 3, and then plus 1. Okay, we can get rid of this at this point. We don't need it. So 1 times 3 is 3, and then 3 plus 1 is 4. So that right there would be 4. And then 0 times 3 is 0, then plus 1 is 1. So let's put that there. And then negative 1 times 3 is negative 3. Negative 3 plus 1 is going to be negative 2. So this is negative 2. Let's close that down. And let's take this to the graph and check it. So coming down here, this doesn't show up very well. So let me change the color of the ink, and maybe that'll be a little bit better. So this point, again, hard to read this, but this is for the first quarter point. This is 13 pi over 24, comma 4. Again, 13 pi over 24, comma 4. Halfway, you have 2 pi over 3, comma 1. Again, 2 pi over 3, comma 1. And then 3/4, you have 19 pi over 24, comma negative 2. Here's your 19 pi over 24, comma negative 2. Again, you have that link on Desmos if you're having trouble seeing it, or if you want to go to the left or the right by one cycle, those points are already done for you. All right, for problem 10, we have f of x is equal to negative cotangent of x minus pi over 3. So this one's extremely easy to work on. I think it's an example where I would definitely use graphing transformations because it's going to be so fast. So first off, let me just put that the phase shift here. We're just going to have this x minus pi over 3. You don't have to factor anything. So really, I want to undo the minus pi over 3. So I need to add pi over 3. So that means I'm going to go to the right by pi over 3. Then for the vertical shift, you'll notice you don't have anything out here. You could put plus 0 to make that crystal clear, but this is going to be none. So let's put none. Okay, in terms of figuring out the graphing transformations here, really, all you have to do for y, you just have that negative 1 that's multiplying the cotangent function. So in terms of y, all you're going to do is multiply by negative 1. And then for x, all you have to do is add pi over 3, because we have a shift to the right by pi over 3. Add pi over 3. Now, because we're not using that other method, we really don't need the period here, but we did ask for it on the practice test. So remember that the standard period for cotangent is going to be pi. And so because the coefficient here on x is 1, you just keep that standard period. So let me say that the period here, again, just for the practice test because it asked for it, is going to be pi. Now I'm going to leave this here. We don't need it. We're just going to grab this real quick, and I'll just come down here and paste this in. So this is all we really need. So just start with the information from the cotangent function. So again, y equals cotangent of x. You have for the vertical asymptotes there, x equals 0 and x equals pi. And then you have the point pi over 4, comma 1. You have the point pi over 2, comma 0. And then you have the point, which is 3 pi over 4, comma negative 1. So all I'm going to do is I'm going to take these x values, and I'm just going to add pi over 3 to each one. So let's start with 0. If I add pi over 3, I would have pi over 3. So for the vertical asymptotes here, you would have x is equal to pi over 3. So let me put and. You would have x is equal to. You would take pi here, and you would add pi over 3. So let me write 3 pi over 3, and then plus pi over 3. So I just took pi, and I wrote it with a common denominator, so I multiplied it by 3 over 3, so that's how I got 3 pi over 3. Then plus your pi over 3 here, that would give me 4 pi over 3. So 4 pi over 3. Coming down, here's your x equals pi over 3, and then here's going to be your x equals 4 pi over 3. So we've got the vertical asymptotes. We just need these 3 points here. And so for those, let me put a little border here, a little border here, like this. I'm going to take pi over 4 here. So let me put first quarter point. So pi over 4, and I'm going to add pi over 3. So this right here, you need a common denominator, and the best you can do is 3 times 4 or 12. So that's going to be your LCD. So let's say this is equal to, you would have 3 pi over 12, just multiplying this by 3 over 3, plus 4 pi over 12,
multiplying this by 4 over 4. Let me make that 3 better. So this would end up giving you 7 pi over 12. So that's the x-coordinate you're looking for. So this is 7 pi over 12. Now let's go to halfway, and then we also need 3/4. All right, so the next one we want to do is pi over 2. And again, all you want to do is add pi over 3. So the LCD there would be 6. So let's say this is 3 pi over 6, just multiplying this by 3 over 3, plus this would be 2 pi over 6, multiplying this by 2 over 2. So that would be 5 pi over 6. Let me get rid of this and just say that this is 5 pi over 6. For the last one, we have 3 pi over 4, and then plus your pi over 3. So again, the LCD there is going to be 12. So this would be, let's multiply this by 3 over 3, so 9 pi over 12, and then plus multiply this by 4 over 4, 4 pi over 12. So this would be 13 pi over 12. Okay, let me get rid of this, and I will write this in as 13 pi over 12, comma, comma, comma. For the y values, again, it's always easier. Here I'm just multiplying by -1. So you're just changing the sign of everything. For 0, it's obviously going to stay 0. So 1 times -1 is -1. 0 times -1 is still 0. And then -1 times -1 is +1. So this is what you're looking for the points. So let me paste this in and we can just check this real quick. So for the first quarter point, you're looking at 7 pi over 12 comma -1. So there's your 7 pi over 12 comma -1. For halfway, you have 5 pi over 6 comma 0. Here's your 5 pi over 6 comma 0. And then for 3/4 of the way, you have your 13 pi over 12 comma 1. So here's your 13 pi over 12 comma 1. Again, I left you a link on Desmos if you want to get the points over here or over here just to get some additional practice. I already have everything labeled for you.